So this is a continuation from part 1. This is part 2 of Law of Signs, focusing on the ambiguous cases. So for this problem, we're going to start off by saying it's actually going to be very different in this case because, well, I'll show you in a second. But basically, we have three different parts. We have this A part, which is saying if you're given the angle 30 degrees and your side is B is 10 and side of A is 4, find angle B. And note the only differences between A, B, and C is that side A can be 4, 5, or 6. And I will tell you, as we're going through this, you're going to note that this is actually going to be different. There are going to be different angles for each one of these, and that's important. And that the only reason they're different is because this side is also different. So, with that case, I'm going to first draw out a triangle, and let's do that in blue. If I was going to say that this is 30 degrees, okay, I'm going to say that this is A, this is B, and this is C, and I'm going to draw a triangle and connect it down here. So if we have that, we have this is A, B, C, undo that, that looks messy, and B, that basically the only thing changing here, and let me do a different color, is this A here. That is the only thing changing, and it actually changes your angle B, this angle here, for each one that side A changes. So let's do the first one together, and I'm going to do that in yellow. So this is part A's work. And now in this case, if I'm trying to find angle B, what I'm going to do is, well, sine of A over A is equal to sine of B over B. And when you do this out, we're going to be looking for sine of B, so I'm going to cross multiply. And actually I'm just going to be left with B sine of A, so those are multiplied together, over A, and that's equal to sine of B. And to get B alone, to actually get angle B, we're going to have to do arc sine. So angle B is now equal to sine inverse of this whole big conglomerated mess, and you can feel free to plug that in. I think I have enough space. So that's going to be equal to sine inverse of, in this case, B is 10 times sine of 30 over, in this case, A is 4. Let me put that as equals down over here. Continue that here. And that's going to be left with sine inverse. 1/2, so it's going to be 5/4 of 5/4. Now, if you already didn't realize this already, look at 5/4. I don't even have to put this on my calculator to tell you that's not going to give you an answer because that is greater than 1. That is a greater ratio of 1. Your y over r, remember that's what sine is referring to, your y is larger than r. It's larger than the radius. So that actually does not exist. And this is where you might say, what? How's that possible? I drew a triangle right here. See? It exists. Well, actually, how this triangle actually exists, so I'm going to redraw this. Actually, let's move this to, I'll redraw another one, and let's do this in red. What happens is, you actually have too short of a side. So A, B, I'm trying to make it as close as possible to this. So, and let's do angle C. You actually have too short of a side A. It's just way too short. It doesn't end it. So we're actually missing this portion. So it is actually not a triangle with that length. So this one does not exist. Actually, do I want to say does not exist? No, this is no solution. So find angle B. And so error, you can say, I guess, error, or I'm trying to think if you want to write your reasoning. Yeah, we'll write our reasoning. Larger than 1, since ratio is larger than 1, no solution. Pretty sure on a test you can just write out no solution. I'll be fine with that. I'm just writing it all out so you can see my work. So this is part A. All right, and now let's work with part B. Okay, so part B here, we're going to do again this whole setup. We're going to do sine of A over A equals sine of B over B. Because the only thing that changes, again, is this. Actually, you know, I'm going to make this, I think I want to make that yellow. That's fine. All right, so we have this whole same setup, and actually I'm going to just jump straight down to this final part that we had in yellow over here. I'll point to it, this. Because the only thing that changes is this 4. So actually, we're now going to have sine inverse of 10. Oh, hang on, I should write what it's equal to. Did not write that. Didn't write angle B. Angle B is equal to, there we go. Now we can keep going forward. Sine inverse of 10, should make it a little bit larger, 10 sine 30 degrees over, now not 4, but 5. And if we do that, you're going to have sine of 30 degrees, which is 1/2 multiplied by 10. You're going to get sine inverse of 5 over 5, which is going to give you simply 90 degrees. So actually, in this case, you do have an answer. You do have an answer, and not only do you have an answer, you have a very specific triangle. You have a right triangle. So I'm going to draw this again, and state, oh, actually that's probably even worse than before. I think my blue triangle was closer. Let's try it. This is there we go, that's much better. And say that angle B, ABC, is a right triangle now. And I do want to state, you might be thinking, oh, let me just box this off. You might be thinking, oh my gosh, how is this possible? What if we switched B and C? Would it still work? Yes, it would still work. I actually show it in this case because I like to see this as a swinging arm. Like that the side A can swing back and forth depending on this difference here, whatever angle B has that changes. If you switch the angles up and reorganize them, I guarantee it would still be the same, though. Feel free to try it out if you'd like. Alright, so for part C, I'm going to immediately jump to our ending bit, which we were talking about again. Sine of A over A equals sine of B over B. And now I'm going to quickly just write this as angle B is equal to sine inverse of 10 sine 30 degrees, but now we have to focus on side of 6, so this must be 6 divided by 6, and you're going to get an answer of, let's just plug this into our calculator, it's going to come out to 56, oh sorry, I should approximate here, 56.44 degrees. Now, I'm not going to box this yet. And you might say, oh my gosh, why wouldn't you box it? Well, here's the reason why. And I'm going to have to really try to be careful about how I draw this. And the reason is, if you were to actually try to get this drawn out, what you might get actually is something like this. A, B, and C. And notice how different that is from these other triangles we have. How we have an obtuse angle here, but not over here for these. Now, why is that important? Because, well, the reason why that is occurring is actually because this side BC, right? This side BC, which is referring to, your side A, this here is so long that actually, if you note, I can actually do this. If I were to draw this like dot out, like make that a border, if I were to redraw this approximately the same length, note that I can redraw that and get this side to connect somewhere else on my triangle. And I'm going to draw this in different colors so we can see how different that is. Well, the color's not that different, but notice that I actually get a different size triangle here. And that's all based on whether or not my angle here that I'm finding for angle B is either acute, or it is obtuse. Now, we saw that with our practice problems that actually, and I'm going to try and do a different color. This is way too close. Let's do, I already have red, so let's just do this brown one. Yeah, let's go brown. That actually, this could be a different angle. This could be now obtuse. So what that means is if this could have been a different angle, what we could say is if it's an obtuse angle, we can say that actually angle B could also be 180 degrees subtracted from this 56.44 degrees. And that gives you 123.56 degrees. And that actually could be the other angle. And I'll actually do this in brown, I guess, to make it coincide for my work. Sorry, I keep changing colors on you. But that's actually our other angle. So there's two triangles or two angles that could exist for part C. So if we actually note and take count of these, we have here, let's bring this back to, I have this, I haven't really used blue, I'll just use blue here, and say that this one actually has no solution, this one has one solution, and this one has two solutions. And by solutions, we mean triangles, because we can make up two different types of triangles. And here, law of sines, this is what we refer to as our ambiguous case. When you're given an angle that is not, so here, given an angle, angle A, that is not an obtuse angle, and it's also side-side angle. So it's ambiguous when you're given a non-obtuse angle. So let's write that in. I'm going to use the green. Yes, blue. So we have side-side angle and ambiguous if side-side angle and not obtuse. Why is that important? Because if you're given an obtuse angle, there's no way you can have another obtuse angle because it wouldn't be a triangle. It wouldn't add up to 180. You can only have one obtuse angle in a triangle. So this is your ambiguous case, and that's also going to be very important for you. All right. I hope you enjoyed this lesson, and I know it might be confusing for you, so feel free to work on some more practice problems that are attached in your Dropbox folder, and I look forward to seeing you all next time. Have a great day.